Hello, and welcome to Senior Code Review Buddy. Today, I'm going to talk about the importance of testing failure conditions. When writing tests, developers will almost always test the happy normal paths, testing that when the function is given good inputs, it works as expected. These are important tests since we want to ensure that the happy path is working correctly. But it's also very important that we test the non-happy, less common paths. What happens when the inputs aren't quite what we were expecting? If I only thought about positive integers when writing a function, what happens if it gets a negative integer? And what about the unusual paths? If there are multiple flags that are passed into a function, optimized equals true or false, dry run equals true or false, are all of those flag combinations tested? When writing tests, it's important to test the cases when things go well and when they don't go well. What happens if a lookup call fails? Is optimized mode actually enabled when the flag is set to true? These conditions will happen in production sometimes, and we want to ensure that our code manages it as best we can, and as we expect it to under these conditions. Alright, let's walk through a few code examples with this context in mind. Alright, we've got a small example here to start. We've got a user class, we've got get user email, which given a user object returns the email from it, and a little test ensuring that the happy path works. And it does work. There isn't much code here, and it's pretty easy to confirm it'll work the way we expect. The happy path also seems to be the only path. There's no if conditions, there's no other returns. So where could there be a problem? Well, in this case, getUserEmail looks like a function that anyone could use. And we don't have any validation on the inputs. So it seems pretty plausible that someone could call it with user equals none. And if a none is passed in, we'll throw an exception when we try to access .email on none. So that's sort of something we should fix. So let's start by just adding a test for this condition. Nothing too complex, just test invalid user. And just self cert is none. Get user email, none. So I think in this condition, we should probably just return none if we're given none as the user email. I think you could make a case for maybe returning an empty string or actually raising an exception and letting the user know that they passed in a none. It's going to depend a lot on the context of where this function exists and what you think makes the most sense there. There is no one size fits all, but in this case, I'm going to go with returning none. So we now got a test. This test would fail. So we would update our code by just adding a if not user return. And that's all there is. Looks much better to me. All right, let's move on to our next example. Okay, so this time we've got a function delete file that has a flag dry run that looks like it's supposed to control if we delete the file or not, at least based on what we're printing here. And looking at the test, we see we've got a nice test testing that when dry run equals false, if the file is there before, we delete the file afterwards. But we don't have anything for dry run equals true. And I've seen this sometimes because we don't expect modes like dry run equals true to run that often, so we don't worry about testing it. But in this case, adding a test for dry run equals true would find a big issue with delete file. Looking at this if statement, what we do is we print that we will not delete the file, and then we just continue and we delete the file. So it looks like there was probably supposed to be a return statement here, and it got forgotten. So whoever runs this in dry mode is going to get an unpleasant surprise of the files actually getting deleted. This is a pretty easy fix, but let's start by adding a new test. So it's very similar to the previous one, so we'll just copy that to start, and we'll call our new test delete file dry run, and then we create the file as before. We make sure it exists, change dry run to true, and then here we make sure that the file still exists afterwards. So if we run this now, this test should fail because we are actually still deleting it. So now we would just change this a return. And there we go. Our two tests should be passing and everything will be better. There won't be any unpleasant surprises if someone runs this code in dry run mode equals true now. All right, let's go on to our final example. This code is from a podcast program I've been working on for a number of years. I've just pulled out a single function, underscore get album from M4A, and the single test it had, test get album M4A. Note, the test doesn't directly call underscore get album from M4A. Instead, it calls get album, which is responsible for routing the call to this function when it is an M4A file passed in. Looking at this function, we've only got one return, but there is an if statement, so there are two flows that could be tested. Looking at this test, though, there's only one check, so I'm only testing one of these paths. Let's see, the name of the file being used here is M4A title as list. Doesn't say anything about whether the album is a list or not, so I don't know which one of these paths I'm testing. So I looked into the mutagen library, which provides the MP4 class, and ran some tests to try and figure out what's happening here. And I actually think it always is going to return a list. So I don't think I need this if statement here. Instead, I'll update the code to just always assume it's a list. But since I'm not 100% sure that's correct, I'll also add a clear assert here. So what we'll do is instead of this, we'll just move that there. And then here we'll just put assert is instance list expected to be returned as a list. So now I've clearly documented my expectations in the code, and if my expectations prove incorrect later, I will know right away and I'll be able to fix it. So I think I should also slightly change the test here. So the related function to this, get title from M4A, does the same thing about assuming if it's a list, get the first element of it. But I think that title also will always be a list, so I don't think I need that if there either. So I actually think that this test file shouldn't be title as list. I think that's just kind of the default. I think I should probably just call this M4A test file. All right, so that's looking better. One thing that jumped out at me, though, looking at this, is this line here. M4A underscore file, getting the M4 tag from it. What happens if this tag doesn't exist? Does it have to exist? This was actually really easy to test. I just took an M4A file, deleted the album tag, and tried to run this code on it. And the code crashed. So I need to fix that. So let's start again by making a new test for this case. We'll copy our previous one and we'll call it test get album M4A value missing. Instead of testing on the regular file, we'll test on an M4A file I created. No title, no album. And we'll make sure that the return value, instead of being this, is helper.noAlbumFound. So now we would run this test. This would fail, which is good. And so we'll update this code with if M4A album tag not in M4A file, return helper no album found. And there we go. I think this code is much better than before. Found a bug and I fixed it, and I think I've made the tests a little cleaner too. Thanks for walking through these examples with me today. I hope in the future you think a little bit more about the failure conditions or uncommon paths you might want to include when writing tests. If you have any comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.